I'm Penny Robotham. I teach at a STEM college in Warwickshire. I currently chair the Olympiad working group, and I've been working and involved with the Olympiad in the UK since 2011. If you're at the meeting today, you've seen the aims of the meeting for you. This is an initiative that Paul and I discussed about trying to get teachers more involved in the process of the Olympiad and how we might better support students across the UK and their teachers in preparing for the examination and the process itself. So we're going to start off with a very view of the UK and the International Chemistry Olympiads, just to give you an idea of where it takes the students. The vast majority of us would never have a student maybe that would make it onto the UK team, but as passionate chemistry teachers, we'd like to get our students involved. And I'm going to talk through some approaches that you might find useful for preparing Year 12 and Year 13 students for the competition. We're then going to review a couple of chemistry test papers and look at the typical approach that the working party use when they're putting the paper together and the range of questions that appear. And also go through how the students might be expected to apply a thought process to those particular questions. And then finally, we'll finish off with a little section on explaining the mark scheme itself, how we've tried to improve the mark scheme over the years, and some of the logic or perhaps not so logical ideas behind it, so that you can use it more effectively with your students. And hopefully it provides you with a whole body of resources that you can use in your classroom teaching. So a little bit of history behind the actual International Chemistry Olympiad. It's designed for talented secondary school students. It's an international competition. This summer we've just held our 51st year of it. I haven't been involved in all 51 years. The students themselves sit 2 5-hour examinations. It's really intensive for them. They sit a 5-hour practical examination, which of course for the majority of UK students is completely new to them, and a 5-hour theory paper as well. You can follow the events that go on at each year's International Olympiad. They have their own dedicated website. They also produce a daily magazine at the time. They have a full opening ceremony like the Sport Olympiads, and you can see in the top right hand corner of your screen at the moment is an image from this year's jury meetings. So we have lots of meetings that run into the middle of the night where we're discussing the questions that the students actually sit. This year there were 578 participants in the Olympiad itself, so it's a very big event, and it was held in Paris in a very, very hot summer this year. Okay, some bleeping. Somebody might have just joined us. At the International Olympiad, gold medals are awarded to the top 12% of all students, silver medals to the next 22% of students, and bronze medals awarded to the next 32% of students. So approximately half of the students who participate would go home with a medal. Unfortunately, half the students obviously go home without a medal itself, but it is really a fantastic experience, and I know a lot of them stay in touch with each other and make lifelong friends. So when they're not doing examinations, there are lots of excursions and trips and opportunities for them to meet students from other countries. There are 2 separate special awards given, one to the student that gets the best theoretical score overall, and one to the student that does the best performance in the practical examination. As far as the UK team is concerned, in 2000, Ruth Franklin from Manchester was the top performing girl and was in the top 10 in the world. Manchester Evening News ran a really lovely detailed article about her that you can still find in the web. There's an article, a screenshot there from the Royal Society of Chemistry website as well. And the lad that you can see on the left-hand side is David Eady. He represented the UK in 2010 as a lower 6 student, so it is possible. I know the paper isn't really designed for them, but David was a lower 6 student. We've had a few lower 6 students since they got onto the team. In 2011, he didn't really sort of mind too much about his A-level courses. He wanted to go back and represent the UK again, and he did, and he finished 3rd in the world, which was our best ever performance. Since the UK has been involved in the competition, we've won a total of 37 gold medals. Sorry, I'm talking about the 2019. 2019 Olympiad this year, there were 37 gold medals awarded, 64 silvers and 95 bronze. The UK, in its 36 years of competing, has received 13 golds. So they're very elusive, they're very difficult to achieve. So those two students that I've just talked to you about are amongst of the students that I know of who have actually been in this very sort of high category in the international competition. The idea of the competition was first developed in the former Czechoslovakia in 1968. They invited several Russian bloc countries to participate, but due to politics at the time, Poland and Hungary were the only two countries to respond. So the first international Olympiad had 3 countries. The UK were first taking part in 1983, and in the 51st Olympiad this summer, there were 80 countries who participated. Round 1 of the UK Chemistry Olympiad has sort of dual purpose, which makes it quite difficult to write the paper. The ultimate aim of round 1 and the goal of the working party is to select the team that will represent the UK that particular summer. So round 1 takes part in January each year. Last year we had over 7,000 entries for round 1. From the 7,000, after moderation, the top 30 students are invited. At round 2, they then sit a practical paper, and they also sit a theory paper. Rather than them just turn up and do examinations, though, because that's not particularly exciting for them, they also participate in a number of lectures and workshops, and they have an evening meal as well in one of the colleges, a reasonably formal meal on the first night, and a much more relaxed meal after the final exams on the Saturday evening in a pizza restaurant, and then they have free time while the working party do a huge amount of marking and sort out the team selection. Once a team has been selected, the team themselves take part in a variety of training. There are international laws laid down that all countries have to abide to in terms of how much training they can take part in, and they participate in the International Olympiad itself. Round 1 paper is where the majority of students would experience the Olympiad. And we try and write round 1 papers with 2 quite different aims in mind. We're passionate chemists, and we want to share our passion for chemistry and try and get students interested in the subject that we love so much. We're the people in the restaurant that when a birthday cake is brought out with sparklers and things like that on it, and they're put out, we're sniffing the air and trying to guess the compounds that we can smell. As well as our desire and passion for chemistry, we also have to select the UK team. We have to select the 4 best students that will represent the UK. And those students themselves not only have to be extremely talented chemists, but they're also required to be able to process new information very, very quickly. Unfamiliar situations to new questions whilst under pressure. So you will have noticed that if you've looked through past papers previously, that there are a number of new situations that are unfamiliar to students studying A-levels. We try and include background information with those questions to then see how students can apply that new information. I'm going to talk a little bit more about why it is a very good paper for year 12 students to sit, as long as we're very realistic with them about their expectations. Very, very able students are not used to not being able to do things, and for a lot of students the GCSEs haven't been particularly challenging. This might be the first paper that they've tried that really does stretch and challenge those particular students. So we've tried to improve the advice that we give to teachers students to try the paper, but I'm hoping to go through with you today some approaches that your students can apply as well when they attempt the papers to be able to achieve higher marks. So if we look at how to prepare for round 1 for all students, There are three basic approaches that I'm going to discuss with you today. The first approach is you would actually integrate the questions that we've prepared and the past papers into your own schemes of works and lessons, a stretch and challenge and interesting areas of chemistry outside the specification that they're doing at the moment. An example of that for me would be I've just taught equilibria and Ka pH calculations to students, and I've used an old question from one of the papers, which is looking at calculating the Ka for methanoic acid from ants, and that was the general context of the question. The questions themselves, as we prepare them, we try and prepare them with a context so that teachers and interested students can see the relevance of the chemistry that they're studying in the A-level specifications themselves, and maybe in an ideal world want to take that further and read more about it. Some teachers might want to run sessions for their students to support them in how they might tackle questions on the paper. So I'm going to share with you some resources that you might want to use when you're preparing for those sessions. And students themselves might independently prepare. We know the workload that teachers are under. If you're a newer teacher and you're lacking in confidence or time to be able to answer some of these questions, you might just want to point a student in the right direction and let them do it on their own. So I'm going to go through some approaches and things like that that hopefully you would find useful to use. In terms of integrating ideas into lessons, there's a wealth of resources there. If you want to start using it with lower 6 students, with year 12 students, you perhaps don't want to go for some of the Olympiad questions initially, and I would recommend therefore that you look at the C3L6, which is a lower 6 challenge, where the questions are targeted at students at the end of year 12, so they're far more accessible for students who are starting year 12. If you follow the links on the presentation that I think you will be getting later on, the C3L6 website here that I'm on now, you can see that if you click on download, you've got all of their past papers. There's also a very, very good skeletal formula guide that they produced, which I actually share with all of my students as I start teaching them organic nomenclature in year 12. So I'd really recommend that paper there. It's very, very good. And we use a variety of those resources. You saw on the previous slide this excellent. It was really a good way of getting students involved on a sort of worldwide scale. Producing 5 questions on a monthly basis after a certain amount of time became very challenging for the group. So unfortunately that doesn't exist anymore. But you can still access all of the questions there, and you've got options here. If you type hint or answer into the box, answer in particular, it will give you the answer to that particular question. When you then type that answer into the box itself, excuse my spelling at the moment. There you go. I think safely. What you will then do is it will take you to a more detailed explanation behind that particular question itself, that you then can use with your own students. And students really enjoy doing those types of questions. So that's a very good site, and I highly recommend it to you. I now need to work out how to get back to the PowerPoint. Nope. I think I'm sharing my screen with you and I can't work out how to get back, so sorry with my technology. There we go. Okay, there's an example there of a question that I've used with my students this year when we've been studying pH. That was a question from 2011, I think. If you've been sat trying to work it out while I've been talking to you, you can check now to see if you're correct. Some of my year 12 students have managed to answer that this year. The idea behind the question was that the students would Google what Michelangelo's David was made up of, which is calcium carbonate, and then once they actually know what the compound is, they can then see if they can apply their chemistry knowledge to be able to answer that particular question there. A couple of other examples that I use with my students I'm about to start teaching my Year 12s the energetics topic. I teach AQA and have marked and previously taught the Edexcel specification. So I use this question as I'm teaching Q equals MC delta T. And again, if you've been doing it in your head while I've been talking to you, that's your answer. And another question that I've used this year with my Year 12, when I've been teaching periodicity and we've been looking at orbitals, I put this stretch and challenge question on for my Year 12 students, and some of them went away and researched it. And that particular orbital that you can see in front of you apparently is the 5FZ cubed orbital that we're all very familiar with, or not. The students find those really interesting to do and good fun, and they're designed not to take a lot of time, and for the students to be able to go and research things outside your own lessons. I incorporate those into weekly challenges. This is an example of a challenge I set for my Year 12 in September. We've been describing the basic structure of an atom, which I should imagine most Year 12 teachers would begin with. We've been reviewing the charges on ions that they came to us with from GCSE. So the first couple of questions there relate to questions that we talked about in the lessons. And this bottom question here is then a question which has been taken from one of the lower 6th chemistry Olympiad papers, where the students then try applying their ideas about cross diagrams and drawing the structures of the nitrate equivalent with carbon, boron and oxygen in there. So I set these as weekly challenge questions for the students, and I have produced mark schemes, and the students self-mark those and just do that as an interesting challenge problem. And I've been through lots of the sort of past papers, starting with the C3L6 and taking interesting questions as we've started, as we've been through our topics. This particular here is one I've just set for them. We have been doing our periodicity topic, and the students then have been applying their ideas about SPD configuration to this question here. This question was a question taken from one of the chemistry Olympiads, and is looking at the electronic configuration of sodium, with a few mathsy questions at the end thrown into it. So the students have been working through that particular question itself. So if we keep Year 12s in mind at the moment, and then we'll move on to Year 13, and we look at the last year's paper, on the front of the paper, as well as the advice that we give to teachers, we do say to the students that the questions will contain material that they're not familiar with, whether they're Year 12 or whether they are Year 13. But if they work through the problems by applying skills that they've learned as a chemist and look at different ways of approaching tasks, that even though they can't complete a certain part of a question, they may be able to find bits later on that are more straightforward. That would be the best message to give to all of your students to help them to be more successful. In an A-level question, if they looked at the question and it was about pH and they weren't very good with calculations, and they looked at the question and went, oh, I really don't like pH, and they get a brain freeze and they just don't want to answer that question, it sort of means the whole question is inaccessible to them. On an Olympiad question, that's not the case. Part A and Part B may be totally unrelated to what's being asked in Part G or H. So the question may start off with a dot cross diagram and then may lead into an ethics question later on. So it's really important that teachers encourage their students to be robust and to give things a go, and to not give up at the first obstacle that they meet. To try Part A, if they can't do Part B, just miss it out, but go and have a look at Part C, because it might be asking something completely different, and maybe asking something that is accessible to them. Very often, the last part of challenging organic questions that we need to put on to the paper to find those students who can cope with those sorts of questions ready for the international. You know, they might be identifying a gas with a molecular weight of 44. Most students would be able to sit down and work out that would be carbon dioxide. So if they keep trying different parts, whilst they might not be able to do the whole question, they will be able to pick up lots of little bits and pieces last year's paper, not the whole paper, don't worry, but just point out, we do sense check all of the questions. The working group itself is made up of lecturers at universities, postdoctoral students, undergraduate students, but also classroom teachers who are familiar with each of the different UK specifications. So where something isn't in a specification, there would be more information provided. If something was in the specification, we would make sure the questions were worded in a similar sort of format with similar language that the students then would be used to. We also try and make sure that, you know, that there's a broad enough range of questions that a good Year 12 student should be able to get a bronze award. And that's what I'd like to sort of demonstrate to you now, just by showing you some of the questions here that we would expect a good Year 12 student would be able to manage at that stage of their chemistry. They won't have covered very much organic chemistry, and I know certain schools teach certain topics, you know, first. We assume that most colleges, most schools probably start with atomic structure. So if we just go through some of the questions from last year, you'll sort of see hopefully what I mean. The first question here was about carbon dioxide, which of course is in the news and a very topical molecule. Hopefully you can hear me. Part A here was asking the students to draw dot cross diagrams for compounds that they should be familiar with from GCSE and certainly from A-level, carbon dioxide and carbon monoxide. The students were then asked to work out the oxidation state of the carbon atoms, and then from the oxidation state just work out what was the difference between them. So if one was +1 and one was +2, the difference between them would be 1. So rather than just ask them to state the oxidation states, they actually had to do something a little bit more with those oxidation states themselves. Moving on, the next part of the question, give students written information to see if they could then turn that written information into an equation, which they then were required to use. So they were told that the concentration of a gas is proportional to the particle pressure. And we were hoping that they would be able to write that as a mathematical expression. We do find that a lot of the questions suit students who are studying A-level maths and further maths, for example, and we see quite a lot of students when we're looking at the moderated papers and they write down the A-levels that they're doing, have that type of combination of subjects. If they'd been successful in taking the written information here and then constructing an equation for it, B part 1 was just asking the students then to put the numbers given to them into that equation that they then generated. So we would hope that a Year 12 student who was mathematically minded would be able to begin to do that. Henry's Law isn't on any A-level specification, but the information was given to the students to enable them to be able to apply that information itself. Further on from that particular question, KC is taught in Year 12. Students have met equilibria on GCSE papers. They may not have met KC at this particular stage, and in this case, this was a KP question. But had they have done, then they would be able to plug the values into their expression for KP. And this particular question was based on one that had appeared on an AS paper a couple of years earlier, where if the students square rooted the KP value and square rooted everything else in the expression, it suddenly made the whole equation much more straightforward to resolve and to calculate. One of my students last year decided actually that the reaction wasn't at equilibrium and rewrote his own question for this, which of course didn't match the mark scheme, so he didn't do particularly well. But certainly we would say that Year 13 students will be able to tackle this type of question, and a Year 12 student that had looked at past papers or had looked through papers may have been able to. By January, students have started studying energetics and enthalpy of reactions, and this question here is a fairly straightforward enthalpy calculation. The equation had been provided and the students, as you can see, are given enthalpies of formation here. So if you're teaching this next topic, then there's a question here that hopefully you could then use with your students in class and then say, actually, you've just answered an Olympiad question there. Well done. Just to put these sorts of questions into some sort of context for you, last year's paper was a very difficult paper. Question 4 in particular was very challenging. But if you have a look, we always award the same number of bronze, silver, gold awards each year. So a harder paper will have lower grade boundaries, but even though it's a difficult paper last year, the sort of grade boundaries are fairly typical. And you can see that, you know, students who are scoring between 11 and 16 marks out of 80 will be rewarded. And I've just highlighted a couple of examples, which are sort of year 12 based questions. And that was just from 2 or 3 questions from the paper itself. About 25 marks on the paper were deemed to be accessible. Given that students won't get everything right that is accessible, they make mistakes. You know, they should be able to achieve a bronze award if they apply their ideas from chemistry to questions themselves. The boundary last year for a silver was 17. It's sometimes a little bit higher than that, but I would say to your students, if they're scoring 21 and above, they're probably looking at getting a silver award. And then the gold varies each year. I think last year it was quite a low grade boundary. But again, if you say to your students, if you're scoring 35 and above, you're probably starting to look, you know, high silver, getting into a gold there. It's not like an A-level paper. It's not like their GCSEs. And I think they find that really unsettling, really different, because they're used to having to get, you know, 80-90% to achieve certain grades, and that isn't the case on the Olympiad, because the paper's trying to do 2 things. Can we get students seeing chemistry in the real world and becoming interested in the subject and sharing our passion? And can we differentiate at the top end, because we've got to select students for round 2 and ultimately for the team. So as I say, it's quite a challenging paper to write. Moving on from that, here's just another couple of examples. Now you've seen that distribution of marks, and you can see where the grade boundaries are. Just where I would say that, you know, I would feel that these would be accessible to a good year 12 student. You're the best judge of that, you're their teachers. But, you know, again, you can see there's a question here that you may want to use when you're teaching SPD configuration with your own classes. And you can say, well, okay, when we are teaching that, have a go at this particular question here. If I take another example, this was from question 3. Question 3A, we're given the structure here of this molecule called PAM that the students wouldn't be familiar with, but part A, part 1 is actually asking them to determine the molar mass of that particular compound. So can they read a skeletal formula, and from the skeletal formula be able to work out the molecular weight? Part 2 here is a mathematical calculation where we've given the value in millimoles, so the students have to do a unit conversion, and the students are asked to determine the mass of PAM required for a particular treatment period. So a sort of mole calculation at that particular stage. Okay. Looking at this question, if the student, so we're talking year 13 probably would be, and a year 12 student may or may not be, depending on what order you've done topics in. The students here are asked to write an expression for Kc for the first step. So you can see the first step here would just be putting products over reactants. There isn't even any coefficients in front of the substances in the equation itself. So that's a nice question for them to be able to gain marks on. We haven't got time to search through questions. We're busy teachers. You've got a huge amount of things to do. At the moment, I'm ignoring the fact that I've got a load of reports to write for tomorrow, and I'd much rather be talking to you. But hopefully you'll find the next resource very useful. Because I've spent time going through the questions themselves. And what I've done is I've created and if you follow this URL link, which appears again at the end of the presentation for you, it will take you to a Dropbox where you can download this particular spreadsheet yourself. So I'm just going to open it up now and show you how it works. Okay, computer just swears at me. What I've done at the bottom here, you've got different tabs for AQA OCR and Pearson Edexcel. Apologies if you do Welsh Board, I haven't matched it to that specification at the moment. I created this a few years ago, so it goes up to about 2018. I haven't updated it with last year's paper. But what you can do, if you know that you're teaching a particular topic area, so let's say we're teaching acids and bases tomorrow, you can click on that particular area, you can filter using that particular area there. And then from there, what you can do is you can see questions that are related to it and that you might then want to use with your own classes. What I haven't been able to do at the moment is link the spreadsheet itself to the actual question. But what it does do, we're looking for question 2 on paper 2005. Hopefully this link will work. What it will do for you is it will open up the 2005 paper, and you just need to go to question 2 and see if you think that is something suitable to use with your particular students. If it opens up while I'm still talking to you, I'll just show you what that looks like. It looks like it's thinking about it at the moment, and I shall ask it to stop thinking about it in a few minutes. So if you follow the URL link or also go to my Twitter feed, you will find the URL link there. My Twitter handle comes up at the end of this presentation as well. If neither of those options work for you, then if you get in touch with the RSC, they will send you the link directly. So the 2005 paper now is opened up for you. And the question itself that we're looking for is this particular question, and this is the one that I mentioned earlier that I've been using with my students. So it was a little picture of an ant here, and then the question is asking the students to write a few balanced equations, and then it introduces pH to them. Your year 13 students, probably you would have covered this by the time you looked at this particular question with them anyway, and then ask the students to work out the Ka value for that particular acid. Okay. So you can filter through different question topics there. What you might find useful is also considering the sorts of topic areas that come up on a regular basis. So atomic structure, for example, and that sodium streetlight example that I mentioned to you earlier was from the 2014 paper. That's not tested particularly regularly, but you'll see amount of substance is a very common topic. If you look through here, bonding, energetics are popular topics. They've come up quite a lot. Oxidation and redox is very popular. Of course, as you know, each year, if I scroll down, there will be an organic question. You'll see nuclear magnetic resonance is something that's quite common that we write questions about. There are some things down here, such as unit cells, which only appear on the pre-use specifications and not on the A-level specifications, but unit cells are quite common, so you've got some questions there. And there's things like chromatography that we've not yet asked a question about, and sometimes we have this in front of us when we're preparing round 1 papers to sort of see if there's any sort of aspect of chemistry that students are familiar with that we could then create a question out of, because it's something that we haven't tested. But hopefully you'll find that a useful resource and something that will be time saving for you and your colleagues. Okay, so I will not save changes to that. There's the URL on the screen at the moment, and again, it appears at the end of this presentation for you. So those are resources that hopefully will save you time in terms of preparation as a teacher, but I said that we would look at how to support you as a teacher and how to deliver this material if you're running support sessions, but also materials that students could work through independently as well. So this book is going a while now, and this booklet was produced pre my involvement with the Olympiad Working Party, but I find it an incredibly useful resource and something to direct interested students to. If you click on the link, you will go to the RSC education booklet, and you can download that particular booklet there in PDF format. Many years ago, they did send a copy into each department, and copies lurking around in your department anyway. Okay, I need to work out again how to get back to the presentation. Apologies, I'm not very techy, as you can see. There we go. Okay, so that support booklet is very good. For a teacher, it takes you through the different sections of a question bit by bit, and helps you then to actually understand how you could approach that particular question. It also obviously does the same for students, so you can give a copy of it to the students and they can work through that independently. There's a very detailed explanation of the famous NMR question that was asked that looked like a dancer, where it helps the students to assign each and every single one of the protons in that particular question. I gave that to some of my year 13 students when we were teaching NMR, when we were looking at spectroscopy. Popped out to get something, came back, and they'd taken every molymod that I possessed and actually made the molecule itself by using the information in the booklet, so they could see all the different environments. So it was very creative, and they found that a really useful resource, and I know teachers have as well. I find it very useful. A few years ago, a really great person called Catherine Smith worked for the RSC, and one of her remits was to produce some support materials to do with the Olympiad. I'm going to drop out of the PowerPoint now and just go directly to the video itself. You can click on it, but my form of the computer doesn't support the video format, so I just have to come out and open it up slightly separately. I'm going to play you a little clip from the video, and you can link directly to it by following the links there. These are on the RSC chemistry website, and enable you, if I just come out of here, it should be open here for us, enable us to actually, again, the students can work through this independently. And what Catherine's done is she's taken old questions and with the questions in a video, and then on the right hand side of the page, as you'll see in a moment, she talks through approaches to that particular question. Again, I've chosen one that is suitable for year 12, and this is looking at the combustion enthalpy of sugar. So if I just hopefully click play for you. I won't play the entire duration, obviously it's a 7-minute, but just give you a sort of feel for how this video works, because they really are an excellent resource.
Penny, the only thing that's coming through is the PowerPoint, and whenever you click on anything on the PowerPoint, we don't receive it.
Oh, what a shame. Okay.
Yeah.
Could you hear the video then?
No, we can't hear either.
Okay, I'm going to come out of the video then and come back. All right.
Okay.
And then maybe people can look through it separately. We've not really tested Zoom to its fullest, and it's obviously an issue that it's got.
Yeah.
You're seeing my screen now with the header on, are you? With the title page?
Yes, we're back to the opening slide from the presentation.
Okay, apologies everybody. You may not have been able to see me manipulating the spreadsheet either then,
No.
but I talked you through it, and hopefully when you've got the spreadsheet open, you'll be able to see for yourselves. Must be a limitation of Zoom, apologies. Anyway, support videos there. Thank you for helping me out with what you couldn't see. I'll move on then. Again, resources if you want to point able students in a direction to be able to work independently. If they don't just want to work through all of the past papers from the UK, they can actually access past papers that have been used in international competitions as well. You can see for yourselves the sort of practical problems that the students are expected to deal with. It's usually an organic synthesis, it's usually some sort of titration and then something else. You wouldn't necessarily be able to do the practicals in your own schools, but there might be some interesting things out there that you're interested in that you could do. But there are theoretical problems there that you can work through. Here's an example of a theoretical problem. So it's not such some students from round 1 and round 2 to the International Olympiad. If you look at part 1A1 here, It's asking for the enthalpy change for the dehydrogenation of propane, and they've got some bond enthalpy values there, bond energy values there. Okay, so students quite like looking at those particular questions, process of mapping those as well to the A-level specifications, and maybe I will be able to share that in a future meeting. If you have EAL students amongst you, the vast majority of my students at my college are EAL students. You can actually, they can download a version in their own national language. So this is a version of the Chinese paper of the same question. It might not mean much to a lot of us, but at least we can still see the bond enthalpy values there, even if we're not quite sure what we should be calculating. But some of my students would work through the questions themselves in their own language, because at the moment in my college they haven't got the English skills to be able to access the English paper at that particular stage. Again, resources for students to work through independently. This book here is an undergraduate textbook that is used at Cambridge University amongst others. It has an online site, and a lot of very interested, keen year 12 and 13 students tend to find this and work through it on their own. And it's something that they find a very helpful resource when I've spoken to my students and how they've prepared for the papers. And if they're interested in applying for maybe natural sciences at Cambridge, Durham, or maybe Oxford and chemistry, they've often been independently working through this book and Claydon. This book itself has got the questions that the students can tackle. And again, I've chosen something that maybe a year 12 student might look at, or a year 13 student, and they can work through that independently. So it's looking at them drawing structures of molecules, working out oxidation numbers and things like that. So again, the students find it particularly useful. The SE meeting a couple of years ago, a company called OpenStax were giving out free copies of their resource. This is the chemistry version. There is physics, biology for your other colleagues. There's a maths version as well. I believe if you go to the OpenStax website, you can get access to this, and their philosophy is it should be freely available to people. So an example of the resource, this is looking at a reactions rates part of the book, but I just wanted to show you how clearly it is presented and how nicely it's set out, and they do various links to additional learning for the students as well. So my students have access to this via our sort of chemistry intranet equivalent, and again, interested students will sort of disappear off and start doing things, clearly if you have a look in the blue box, beyond A level, but things that they might be interested in if they're particularly keen on a topic. And that's a free resource that is available, and the providers are called OpenStax, so I thought you might be interested in that. For the next part of the presentation, I just want to talk about some approaches that students can use to questions. And I thought I'd share with you approaches to the synthesis of Viagra, and for obvious reasons you may understand why the picture is censored. So let's have a look at part of that question here, and how students might approach this question, and what you can do with them to give them some support with it. I've deliberately chosen an organic question because the organic questions are challenging. If you were talking a year 12 student, they almost certainly have covered very little organic chemistry and don't have the background knowledge to be able to answer the majority of the question. And the year 13 students would find it challenging as well. So just want to share with you some approaches to make bits of the questions accessible for them. The first thing I do with my students, once they're familiar from that C3L6 sheet that I talked about interpreting skeletal formula, is we look at these molecules here, molecules A and C, which are part of a synthetic route for Viagra. and we asked them just to spot the difference between the molecules. So we've done some work on functional groups. I used this on Tuesday with my year 12 students. They've done basic organic nomenclature. They have learnt about functional groups. They understand that you can interchange functional groups. We haven't taught alkanes and alkenes. The first organic functional group that they come across is alcohols, because they don't need any prior understanding about things like polarity, intermolecular forces or anything. It tends to be a level playing field. They just, from alcohols, can understand that you can convert a functional group into different functional groups. So we've looked for very basic knowledge that they've got. They were able to spot the difference between these two different compounds here, and then they were able to also name the functional groups, but it didn't matter if they couldn't. They didn't obviously know the name of this 5-membered ring with the two nitrogen atoms in it, but they knew that it was an alkene bond in it. With the two functional groups then, they sort of highlighted the difference between molecule A and molecule C. What I then asked them to do was to work out the molecular formula of A and C, and we looked previously at a question where the students have been asked to work out the molecular formula of PAM, so I'm practicing skills with them that would also be useful for the Olympiad as well. The reason why I've used that approach is once they understand that the main backbone of the molecule is going to remain unchanged, and you're just probably fiddling around with changing a functional group into something else, that the molecular formulas of the compounds can sometimes prove to be very useful to them. So they were doing those two activities at the start of the lesson. What I then did is I gave them the first part of the synthetic route to Viagra, which was this bit here. The molecular formula were given to the students in the actual examination question, so they were able to check that they calculated them correctly. They knew now that the difference between A and C was the appearance of a methyl group on the nitrogen atom, replacing the hydrogen over here, and that the ether link down here had been converted into a carboxylic acid group. They're not familiar with this particular reagent, CH32SO4. They don't know what that does. We wouldn't expect students to. But if you have a look, they can take the molecular formula of the compound A, compare it to the molecular formula that was provided of compound B, and they can see that the difference between A and B is a CH3 group. So students then have got an ability to be able to redraw A, replacing the hydrogen with the CH3 group, and now they've got an extra mark that they may not have otherwise been able to achieve. And then going from B to C, they're able, maybe some of them, to suggest what a reagent that might do that particular conversion if necessary. But you know, they've gained an extra mark that students might not be expected to get when they initially look at an organic synthesis. The organic synthesis questions themselves are designed so that a student can work forwards to a particular point, and then if they get stuck and no idea what C is, I can't get any further with the question, they may be able to work backwards from the diagram of the target molecule and be able to get D from working backwards as well as working forwards. So if you can encourage your students to do that and to persevere with a question, and if they can't do part of it, to not worry about it, just leave it and move on, and maybe they can do another bit of the question. It helps them to build up the marks that they need towards that bronze or towards the silver. You know, they don't have to get the whole paper right. It's about getting bits of questions right, and the paper very much rewards students who have a go. To give you a case study of that, I taught a group of students a few years ago who within the group, ultimately the lad I'm going to talk to you about achieved an E grade overall at A level, and the girl that I'm going to refer to got an A star at A level. So very different abilities in terms of their A level chemistry on A level papers. On the Olympiad papers, both students sat the round 1 Olympiad in year 12. The girl panicked when she looked at the paper because she wasn't used to being able to apply herself outside things that had been specifically taught to her. And she managed to get a bronze on the paper, which is really a good achievement for a year 12 student anyway, and I was really pleased. The boy, however, was the type of person that would just take risks and just wing it, really. It's probably the best thing. So when he looked at a question like this, chemically, he'd got no idea what KCN would be doing in the reaction between A and B, not a clue, either at the start of year 12 or clearly by the end of year 13, if you consider his A-level result overall. But he just took risks, and what he did is he wrote something on all the questions. He just wrote an answer down and had a go at things. And he actually got a gold, unbelievably. So an E at A level, but actually a gold in year 12 on round 1. So it is very much worth encouraging your students to have a go and just try things. And it doesn't matter if you're not right, because it's a low stakes test at the end of the day. They never have to share their results with anybody if they don't want to. We all know it looks very good on UCAS applications, and that's why there's a greater proportion probably of year 12 sitting the papers than year 13, because by the time the paper comes around in year 13, most of the interviews and the personal statements are all sort of in place and have taken part, haven't they? So really encourage your students to have a go, give it a go, and they'll be rewarded, hopefully, at the end of that. The final part of the session this evening was to share with you a little bit of rationale behind the mark schemes, because they are different to an A-level paper mark scheme. They don't penalise things that would get penalised, and it's not always clear where marks are awarded. We're trying to make that clearer for teachers, but I just wanted to highlight to you about why we award marks for certain things that might not appear obvious to your scheme. We had some difficulties with moderation a couple of years ago where applying half marks was done inconsistently. So we've now got rid of all half marks. The question is either right and it gets given a full mark, or it's wrong and it doesn't get a mark at all. We do carry error forward, particularly with a calculation, as you would on an A-level paper. It does say on the front of the mark scheme, if the units are missing, penalise it once on the whole paper, but don't penalise it every time. If a student has shown that they can do the mathematical calculation and the answer's right, we'll give them the mark for it. You know, they deserve to be rewarded. Okay. We accept organic structures in all sorts of different forms, so skeletal, displayed, as long as you can read the connectivity between the atoms, that's fine. I'm sure the students not including state symbols at A-level is a big bugbear for you, because they lose lots of marks at A-levels when they don't do that. That is not penalised on an Olympiad paper. So that's a little bit of information there about, you know, hopefully how you can apply the mark scheme and things that you may or may not want to share with your with your own students. I certainly don't tell my students that state symbols don't matter on the paper, because I have a big enough problem trying to get them to include them normally when they do matter. In the question that we saw initially about carbon dioxide, where the students were asked to draw dot cross diagrams, because we're not now giving half marks, although it's not terribly challenging, both of those questions there were given a mark each. They've got to demonstrate a certain level of skill for carbon dioxide, so that was discerned to be credit worthy of 1 mark, and similarly for carbon monoxide. When they're working out the difference between the oxidation states of carbon in carbon dioxide and carbon monoxide, we have put a little bit of extra information for the students, so that if they refer back to the mark scheme themselves, they can see how we arrive at the final answer there. And both of those types of questions, each answer that the student has given has been awarded a mark. Obviously, drawing a dot cross diagram or working out an oxidation and less demanding than if we look at question 4 from last year, some of the crazy structures that the students were expected to be able to draw. Again, this idea that there are easier, more accessible marks later on if you persevere is highlighted at the bottom of this question here, part J. If students looked at the mark scheme, it was fairly trivial for students to work out that reagent X in the reaction scheme was chlorine. And a lot of students have come across the chloride radical. So there were some easier marks at the end of that question, although some incredibly difficult marks before that. Here, with the organic structures that I've shown to you here, 1 mark was awarded for V, the radical species, and 2 marks were awarded for W. There aren't half mark credits for, you know, can you get W part right, or you know, do I then give 1 mark for it? The reason 2 marks are awarded for W is because W is considered to be a harder structure to be able to determine. So if you compare that to, you know, CL2, it's more credit worthy than writing CL2 for sake of argument. You'll find that a lot with the calculation questions, that, you know, the students might give an answer and then we say that particular answer is worth 3 marks because they've had to do a huge amount of thinking to be able to get to that particular answer. And that particular numerical answer is much more difficult to achieve than just drawing a dot cross diagram, for example. So I hope that sort of explains a little bit about how to use the mark scheme itself, and you know, we're not giving half marks for a structure being partially right. We're trying to reflect in the mark scheme the level of demand that we perceive that particular answer to be in comparison to other answers that a student might have already given. Okay. That brings us to the last part of the presentation now. We've tried to keep it down to an hour for you because I know people are very busy. We hope now that you would be able to have strategies that you can use in your own classrooms with your own students, and that you would be interested in entering students for the Olympiad itself. We're always grateful to receive feedback and comments from teachers, so I'd be interested if you would want to run similar webinar sessions to this in the future, if this has been useful this evening, if there are other topics and other areas that you think might be useful either to yourselves or to your own students. The URL is given there for you if you're interested in downloading the the Excel spreadsheet that I used and scrolling through that. And after I finish the presentation this evening, I will upload my Twitter feed also with that particular details, that URL as well, and I'll do that as a pinned tweet for you, so you can access it that way. Paul, I think if you will be able to see if anybody's typed in any questions, you might be able to sort of share those with us so we could answer them directly now, or we could follow that up later with people in, you know, via email and things.
Thanks, Penny. The only question that I've seen is somebody asking, can they take it in both years of?
Yes, absolutely. No reason not to at all. We responded to feedback from schools a few years ago that they said that in some schools it was very difficult for the students to find a 2-hour block to sit the paper in. So the papers are split now each year into 2 1-hour papers. We do advise that it's sat as a 2-hour paper where at all possible, because if a student can't do a particular question and paper 1 has been taken off them, they may have been able to use some of that time to go back to a question that they could have done, whereas if you know, half of the questions are taken away, that they can't go back and check it. But we did that in direct response to feedback from teachers who said that's what they needed. And certainly the students can sit it. They can sit it, you know, there are a very, very tiny proportion of students who sit it in year 11. And then there are, you know, a lot of year 12s and year 13s, and they're welcome to sit it both years.
That's great. A couple more. What is the deadline for sitting it?
We have a window for people because we understand that, you know, having a specific day to sit it, like the British Maths Olympiad this Friday at very short notice, is very challenging for schools. So on the RSC website, you will see a window. And the window is usually a 2-week period, and the students can sit it at any point as convenient to the school. We trust the themselves to apply usual examination procedures, that the papers will all be collected in at the end and not given back to students until the close of the examination window. So if you have a class that can only sit it on a Monday and you have another class that can only sit it on a Wednesday, that's absolutely fine. It's designed that we would like as many students doing it as possible, and we completely trust teachers and their professionalism to keep the papers secure until the end of the window itself, which I believe this year is the 23rd of January is the date. It's on or around then.
Mm-hmm. That's great. One more, can we provide students with both the language, both English and Chinese papers for the competition itself, for the
sorry if I've confused people. The Chinese version of the paper that I showed you there was an international paper. We don't translate the round one paper into lots of different languages, I'm afraid. We don't have time to do that. If you have got an EAL student, the normal procedure for EAL students in any examination is they would be allowed to use a word-to-word translation dictionary. If you in your professional capacity as a teacher felt that a student needed that, then the student could use that same word-to-word dictionary. My students a few years ago, my students were all Chinese a few years ago, and there was a question about algae, and they hadn't got a clue what algae was, so they did need that explaining to them. So professional judgment, but we don't produce a fully translated paper, I'm afraid.
That's good. And one more question, do we need to do anything now? Well, they need to register, don't they?
Yes, the registration window is now open. You may want to direct your students to resources that they can be working on over the next sort of 6 weeks if they're interested. But you just as a school at the moment need to register your interest, and then you will be sent a secure copy of the paper at the start of the window. You print that off yourself, as many copies as you need. There is a paper and there is also a separate answer booklet. So the students write all of their answers in a separate booklet, and the mark scheme is released at the close of the examination window to keep it secure once everybody has had an opportunity to sit the paper itself.